Hello, my name is John Harbin, and I'm going to speak today about software architecture as it relates to cloud services. Cloud services become so integrated into every part of our lives that most of us take it for granted, but it's interesting to look at the architecture that structures these services to see how the choice of style and pattern affects operation. Ultimately, what are the goals of cloud services, and how does the architecture of these services assist in accomplishing those goals? And real quick, we learned about software architecture in Module 4, and it's also in Chapter 5, Sections 3 and 4 of the text. So those would be good sources to use as a reference. Okay, first we need to define cloud services. We've all used the cloud, or perhaps backed up an iPhone using iCloud, but what really is cloud services, cloud computing? Um, Cloud services are basically a delivery system. It delivers services to users. We're mostly familiar with the storage uses of cloud services like Google Drive, iCloud, but the cloud systems really can offer a lot more than that, and do offer a lot more than that. Some offer applications for end users, some offer actual computing power, and that's all in addition to the data storage functions that most of us associate with cloud services. Okay, there are many goals or reasons behind different cloud services, and of course those goals are going to change from user to user or provider to provider. But I'm going to focus on the following three because they're almost universal goals for any cloud service. First, to create a system that allows the average user without much experience to utilize services that might otherwise be unavailable, like a business applications, like business applications for a small business, without the need to create an internal infrastructure or to maintain installations and updates. Second, it allows users, both personal and business, to control costs. Um, this can mean either lower hardware and IT costs, or it simply can create a steady, trackable expense. Um, an expense, you're charged an expense to use the service per month. That's easy. It's the same every month and it's trackable. And last, it offers mobility to users. This can mean, obviously, it can mean mobile technology, which we all know has become integrated into modern life. But it also can mean mobility of information, data, and resources, like an employee not being bound to one office or location because those applications and all the data can be accessed anywhere. So what does this have to do with software architecture? Architecture is a set of principles, or it's a pattern of a system, and the architecture defines the system's form and function. So basically it's the structure of the system and it provides direction to the system. So it's important to look at the architecture of a cloud service and look at how that affects the goals. So I'm going to focus primarily on the layered architecture, layered style of architecture, and how it affects cloud services. Um, it's one of the most widely used styles, and it's applied to cloud services a lot. Quickly, just to review the layered architecture and what it is, it's a system that is divided into modules or layers, and all these layers are stacked. Each layer provides information or services to the layer above it, and it is possible for the a layer in the structure to actually get information or services from any layer below it, but that's called a relaxed style, and it actually more highly couples the layers together, so it offers less flexibility. Each layer is partitioned. It only contains single units of the system, um, and those units are separated from each other, so it offers it offers more flexibility. And then the interface within these layers is very well defined. Okay, this is a graphic that displays the layers of a cloud service. Obviously, these can change a little bit from application to application, but this is what we're going to focus on in this presentation. Okay, at the bottom you have the hardware layer. This is the initial layer, physical resources. It's how they communicate, the servers, the routers, etc. Switches, cooling. Um, It's the physical setup, usually in the data center or whatever the centralized location is. Um, and this layer it's how they communicate, and also how they communicate to the layer above it, which is infrastructure. Um, this layer divides the physical resources, and it uses various tools to allocate those resources. And it's important to note that these tools, um, they can be developed. They also can be developed by a third party, and they may have their own architecture within them. So you can mix and match architectures, but we're really just focusing on the cloud service architecture and not necessarily the internal parts, third-party systems within. The next layer would be the platform layer. It's basically the operating system. It holds the cloud applications and the framework for those applications. And the final layer, the application layer, this is the layer that most end users see. And it's usually accessed through a web browser. Like, you go onto Google Chrome or Internet Explorer, Firefox, and you access the Google Drive. So, most applications, most cloud services utilize a browser to access their services. Off to the side of the layers, you see infrastructure as service, platform as service, software as service. And this really also serves to highlight why it is beneficial to create the cloud service in a layered format. Because the infrastructure service that really encompasses, data storage or computing power. So it's good to have that layered off, those systems in its single layer rather than integrated into the other layers. Same for platform as service. You can see in the graph on your right there, this is usually a layer that hosts application development tools. It holds the infrastructure so that maybe a business or a user, a contract user, doesn't have to have to go through having that storage, having that application on their home device. And then obviously software as a service is what most of us are familiar with, through a browser or specific third-party applications. And you see there, it gives the examples of Salesforce, NetSuite. So how does this architecture, the layered architecture, how does it help serve the goals in the cloud service? The first way is it really does offer mobility and ease of use. By separating the offered applications and the operating system and the storage capabilities entirely from the end user hardware, the users can access these services from any device. They don't have to install it. They don't have to maintain it. All of that is handled by a third party at a centralized location, so it can be accessed from multiple computers across multiple locations, multiple devices. A lot of times it can be offered it can be accessed from a smartphone or a tablet. So it does offer mobility and ease of use. Ease of use because any user can use it. Most of these services with minimal training. Most everybody knows how to use a browser, so that's a benefit. Reusability, because the system's broken down into layers, it can be repurposed for a wide range of enterprises and applications. And all you have to do, a developer has to do, is modify maybe a single layer or maybe two layers to fit an application, and they don't have to necessarily rebuild the entire system. So it's really high reusability. And then user costs. The users only need to access pre-installed browsers. They don't have to pay licensing fees for a lot of software, the application software. They don't have to pay internal IT costs to maintain the software, to maintain the hardware. Basically, most companies or private users, all they have to do is maintain their personal computer. Okay, real quick, we're just going to apply this to some real world examples. HIPAA certified medical record storage. If you're not familiar with it, HIPAA is the Health Insurance Portability and Accountability Act. It's basically what protects our medical records. Cloud services are beneficial here because obviously medical records, most of the population has medical records of some sort. It's a huge amount of data. Storing it in just a single physical location, in today's age is just not feasible. It's not. There's not much access. And then having medical professionals pay to store it on site through, with the hardware, storage hardware, is a cost that not many people can bear. So it's really useful to apply this cloud services to this application. And one of the benefits of a layered technology is that there's minimal training involved for technicians and medical professionals in actually applying HIPAA to medical records, because the developers have taken that application layer and the platform layer and programmed it in a way that it automatically applies the privacy protocols through the application. So rather than having to go through and train professionals how to physically protect the records, it's done automatically. Reusability. If you look at the medical record storage and something like Google Drive, they're two completely different applications, but they're really the same principle. You're storing files in a centralized location, and this really serves to illustrate the ease of use as well, because the medical record storage simply has a more intricate end user interface. And also it has that in the application layer. Developers have really made two different modules: one a view only, read only through a browser, and also a data entry application that most medical professionals use. So where Google Drive just is accessed through a browser and is a basic download and upload of files, the medical records system has taken that application layer and reprogrammed it to not only use the browser but to also use a third-party application. So both of these can use the same layered structure or basically the same layered structure, and just change how the application layer handles the information. They may have to add, and then also maybe in data storage, that side on the infrastructure or the hardware layer may have been changed to add security, but the structure is still the same. So there's a lot of reuse between these two types of applications. Finally, user costs. A layered architecture allows data storage and services to be in a central location, and that's unlike something like peer-to-peer file share service. That's another type of architecture. Although there are cloud services that are peer-to-peer, the layered architecture provides a lot more benefit in a lot more applications. And there are other styles that allow central storage, but they often require a more client-side intensive operation and or software like repositories or a client-server setup. The platform layer provides the application and access to computational resources rather than using the user hardware. So the hardware costs are minimized, maintenance and setup is minimized, sometimes eliminated. And then, again, the software and the licensing costs are far reduced. And like we said before, for enterprise users, the cost becomes regular, easily forecasted. It's just all that you have is the pay for the access to the service. So, in conclusion, cloud services, cloud computing, it's become fundamental. It's an integral aspect of modern technology, of modern day life. We all use it in some form or fashion. So it's really important to look at how the architectural style affects the systems, how the goals of the systems are realized by these architectural choices. The layered style of architecture really does lend itself to cloud computing, to cloud services model, simply because it offers a high aspect of reuse. Developers are going to be, using cloud services a lot. It's much more cost effective for them to be able to look at what's already been done and translate that into whatever application they're using. It does offer a high ease of use because it creates a system where users can use familiar technologies like browsers to access these applications. Um, and finally, it is an excellent way to control costs. Um, the way it takes the hardware, puts it in a centralized location, the IT cost, everything is reduced to just an access fee. So, um, thank you for listening. Thank you for taking the time to look at this with me. Finally, I've just included some references here if you want to do a little more research. This is what I used. So again, I appreciate it. Have a good day.